Empire splash target. Returning to Mother.
Contact the field, your mark. Bar locked.
At Mach 1.2, the F-35C is moving through highly compressed airflow. Its internal weapons bay now becomes a critical aerodynamic zone. When the F-35C opens its weapons bay at supersonic speed, violent turbulence surges back into the cavity. In just a fraction of a second, this turbulence can deflect the weapon immediately after release, pushing it dangerously off course before safe separation is complete. Opening the weapons bay exposes radar reflective surfaces, briefly increasing the aircraft's radar signature and making it easier to detect. Inside the weapons bay, a pneumatic ejector prepares the weapon for a rapid, controlled separation from the aircraft. A pneumatic ejector throws the missile clear at 10 meters per second in 1/10 of a second before motor ignition. Small aerodynamic fences help control the airflow, while high-speed hydraulic actuators close the weapons bay in under 1 second, restoring the aircraft's stealth shape.
Inside the sealed weapons bay, heat from the nearby F-135 engine gradually builds around the stored weapons, creating another critical thermal management challenge.
A PAO coolant loop circulates around the weapons bay, carrying heat away from the stored ordnance and keeping temperatures within safe limits.
Once safely clear of the weapons bay, the missile motor ignites in clean airflow, completing a smooth and controlled launch.
With the weapon released, the bay doors close rapidly, restoring the aircraft's stealth profile for continued flight.
Frankie, make sure it's a coupling here.
Deck geometry and island safetyometry and island safety limits reduce flexibility, directly affecting fuel and payload margins.
At maximum takeoff weight, the F-35C must accelerate nearly 32 tons from 0 to 250 kilometers per hour in under 2 seconds.
Traditional steam catapults produce a sharp force spike at the start of the launch. This places heavy loads on both the airframe and the pilot. Beneath the flight deck, EMALS uses stator coils stretched along a 91-meter launch rail to drive the shuttle with precisely controlled electromagnetic force. Unlike steam catapults, EMALS adjusts current millisecond by millisecond, building thrust smoothly and cutting mechanical stress on the F-35C by about 20%. Motor generators store kinetic energy. Power conditioning electronics channel it to linear motors beneath the flight deck, driving the launch shuttle that sends the F-35C to launch speed. The F-35C's larger wing area combines with 30 knots of relative wind over the carrier deck, rapidly building aerodynamic lift.
As airflow accelerates over the F-35C's wing, pressure drops above, while higher pressure below generates the lift needed to clear the carrier.
EMALS power output nominal. EMALS automatically adjusts launch force to the exact weight of each F-35C, whether heavily armed or lightly loaded.
With a smoothly controlled launch, the F-35C clears the carrier without the pronounced nose dip seen in earlier generations.
Without waiting for steam pressure to rebuild, EMALS can reset for the next aircraft faster, increasing launch tempo by roughly 33%.
With the deck checked and debris removed, the launch crew signals that the next F-35C is ready to move into position.
Six triple flight launch, ready Hero.
Next episode, how much power does a 100,000-ton carrier need, and can 2 nuclear reactors supply it? Subscribe to Inside World.